Hello everyone. So today we are going to look at another question in our array series, which is move zeros to the end. So in this question, what we are going to do is suppose we are given an array which includes some zeros at different places. Suppose here it is at second index, it is at third index, it is at last index. Okay. So what we have to do is we have to take all the zeros and put them at the end, like three zeros at the end. Okay, and we have to put the rest of the numbers to the left side without disturbing the order. So without disturbing the order means, see, if we look at the non-zero numbers here, they're in order like 10, 5, 8, 9. Okay, and when we modify our array, the numbers should be in the same order, like 10, 5, 8, 9, 10, 5, 8, 9. All right, so this is the main idea. Cool. Now pause the video and think of the solution. Okay. Now let me tell you how you can like solve this. First, let's talk about a nice solution. And I guess like many of you might have approached and cracked this nice solution. So what is happening here is, yeah. So what is happening here is we are using a loop which runs from, let's write our array first of all. Okay, 10, 5, 0, 0, 8, 9, 0. Cool. What we are doing here is we are running a loop from 0 till n, till less than n, and here what we are doing is that if at any point our array I is equal to 0, okay, suppose here our array I becomes 0. Right, now we will use another index j which will run from this part and will go till here. Okay, and we'll see if there's a number which is not 0. See here, if array j is not 0, so suppose 8 is not 0, so what we are just going to do is we're simply going to swap our element at ith index, which is 0, and element at jth index, which is 8. So our array now looks something like 10, 5, 8, 0, 9, 0. Now I gets incremented here, right? Again, see, if ARR is equal to 0, we'll run j from this point till this point. We'll see that this element is not equal to 0, so we'll just swap this element 9 with 0, and this would be our resultant output 10, 5, 8, 9, and we'll again run for this. Okay, it will again check ARI is equal to 0. Then we'll run a loop from j till n, but we won't be finding any non-zero numbers, so this is how the loop would end. Okay. Now talking about the time complexity here is, see, there is this loop and there's this loop, and see that both are these are nested loops, one loop inside the other. So time complexity of this loop can be said as n. Okay, and this is n, so the overall time complexity would be n square. Okay, this is 2. Cool. N square. Now since we have talked about the nice solution, now think of another solution, a more efficient solution, a solution which can be done in big O of n time. All right. think for 2 minutes and try and solve it. Okay, let's talk about efficient solution. Cool. So what are we saying here is that we need to solve it in big O of n time. A better solution would be big O of n, right? So um yeah, okay. First of all, let's write our input array 10 5 0 0 8 9 0. Cool. 10 5 0 0 8 9 0. Okay, now we have to use a loop. We'll, have our iterator I here initially. Okay, now let's talk about an intermediate position when I is some random number. Okay, so since we are using a single loop, if our suppose there is an array and these are some of its number and I is pointing somewhere here and there are the rest of the numbers. All right, I is somewhere here. Here are few numbers, suppose A1, A2, etc. etc. And I is pointing here. So what I'm saying is that this A1 till let's say I minus 1 A0, let's say it A0. These numbers would be the, in the correct form. Okay. Meaning that these numbers sorted in the way they should be. Okay. That means that the non-zero elements would be at the left side and the zero elements would be at the right side of this. Okay. So let's talk about the solution. Okay. Suppose I here is I is points are pointing here. Okay, let me clear a little bit. Uh, yeah, cool. So what I'm saying is suppose I is here. So see, I'm till I minus 1, the array is as the way we want the numbers. Okay, and suppose I comes here, we'll see that the non-zero numbers are to the left side and zero numbers to the right side. Okay, so this would also pass. We'll come here. Okay, we'll see that the non-zero numbers are to the left side and zero numbers are to the right side. Okay. Now the case would arise that whether this number is 0 or non-zero. If this number is 0, we'll just simply move forward. Like in this case, what we did, saw this number is 0, we just simply move forward. But here it is a non-zero number. So what we have to do here is we have to replace it with the first occurrence of a 0, which that is this number. Okay. We have to replace these two numbers. So we have the index of this number as I, right? And what would be the index of this number? Can you tell me? Think for a bit and tell me. Okay, you may have found the correct answer. It is the number of non-zero numbers occurred before. Okay, think for a bit. Think again. What I'm saying is the index of this element is the number of non-zero elements before it. Suppose, see here, the number of non-zero elements are what? 2, right? So index of this is 2. So we'll just swap this and this number. It becomes 10, 5, 8, 0, 0, 9, 0. our I will reach here. See, for 0 to I minus 1, the array is the way we want, non-zero numbers to the left and zeros to the right. Now we'll see this element. This is a non-zero element. We'll swap it with the first recurrence of 0. What would be the first recurrence of 0? What will be the index of it? The non-zero elements before it, 3. Right? So 0, 1, 2, 3. This element index is 3. We'll swap this with this. Right? And this would become 10, 5, 8, 9, 0, 0, and 0. Okay. So this is what we have to do. Now see, our I will come here. It is a 0 number. It won't do anything. It will just increment. It is again 0. It will increment. It is again 0. It will increment. And I would become n, and we'll come out of the loop, and we'll get the correct array. Cool. So let's try and code this. Okay. Let's make move zeros dot cpp. Cool. Let's include header file. Okay. Let's have our int main function. We'll have int ar as it is 10.5.0.0.8.9.0. 10.5.5.0.8.9.0.0. Okay. Okay. This will also work, right? Or we can do one thing is, let's have another element here. Cool. There are like 0, 8, 0, 9, 0, 0. Okay. Let's have like cout before operation is equal to 0 while less than. How many elements are there? 1, 2, 3, 4, 5, 6, 7, 8. We will simply cout I. Alright, now let's do this. Where we'll have ARR, comma, size of it. Okay. And we'll write cout as after operation end cout okay, this will work, right? And let's make our move 0 function now, which is our main part. Let's hide the index int main part, int arr 10. Okay. ARR is what? Input size, input array, and n is input size. Okay. Let's have a variable int count. So what this variable is going to do is, this variable is going to have the count of non-zero elements. Okay. Now let's write a function for int I is equal to 0 and is n I plus plus. In this loop, suppose if arr I is not equal to 0, what we are going to do is we are going to swap arr I with arr count, and we are going to increase the number of non-zero elements. Okay, and if the element is 0, we are just going to simply pass it. Okay, now you might be wondering like how we can just swap this arr right with arr count. And okay, let's have a dry run here. Okay, what I'm going to do is I'm going to clear a bit here, and we are going to have a dry run of this code. Okay, readable. This is readable, right? Let's see the code again. What we are doing here is we are maintaining a variable count, which will count the number of non-zero elements that occurs, and we put them to the left side. And we are going to use a loop, and at any if we encounter a non-zero element, we're just going to swap it with the element at the count index, and we'll just increase the count variable. So okay, at initially I is what, 0, count is what, 0. We'll see that this is I, right? We'll see what, that I is what, 0. See, if error I is not equal to 0, error 0 is what, 10, which is not equal to 0. So we are going to swap it with error count. What is C, 0? That means swapping 10 with 10 itself. So that means the 10 would be here, and then we are increasing C plus. So in the second iteration, C becomes what, 1, and I becomes what, 1. What did we see? This is also not a 0 element. So we'll swap AR I with AR C, which is 5 itself. So we'll swap 5 with 5. So no changes till here. I will now become 2. C will become 2. It will come here now. It is a non-zero element. We won't do anything to C. We'll just increment I. Now I will become 3 and C will still remain 2. We'll come here. We'll check that it is a 0 element. So we'll just increment I to 4. And C still remains 2. What is 0 going to? Then we'll come here. Now what we check here is that this is a non-zero element, so we'll swap this with a count with number. Count is 2, that means we'll swap it with this. So this will become 8, and this will become 0, and count will increase. I becomes now 5, count is what, 3. Okay, 5 is here. We again encountered a non-zero element. We'll swap it with the count index, which is 3. This is 3, right? So we'll swap this with this. So this will become 9, and this will become 0. Okay, now I'll become 6, C becomes 4, Again, there's a zero element, we will just increase I, and now I will get out of range and we'll just come out of the loop and see the array is being modified. Okay, so this was, the code. So this was the whole code for this question, move zeros to the end. So here you learn two important things. One is that um, this algorithm can be used where maintain a variable for a specific thing and you can replace it with another things. All right, and in the starting of the in the starting of this series, we talked about the asymptotic analysis and why is it important. So you can see the importance here. We talked about a nice solution, right? It is an easy code, but what did we see here? That this nice solution um, does the work in O(n) square time, right? But the efficient solution works in O(n) time. So the second solution is obviously better. So we talked about that also. So I guess the solution of this problem would be clear to you, and this was it for this lecture, and see you later.